Hello, everyone, and welcome to our next workshop of QUICKSURFACE. As you know, we would like to wait a little bit until we get more people. Some people just join 1 or 2 minutes later. And I'll use this opportunity to introduce myself and Viktors. I'm Kosta Vranceliev, and I am the head of the products of QUICKSURFACE family. I mean, QUICKSURFACE standalone and QUICKSURFACE for SolidWorks. This is not exactly a webinar. We call it more workshop. The main idea is we just get here together and we encourage the participants to ask questions. The main idea is that we're going to show you a workflow with QuickSurface Pro. Viktors is our lead application engineer. He's very experienced with the QuickSurface. Whenever I just look at the object and I just get frustrated, he's here and then I like what he says. Oh, that's super easy. Let me just show you how to do this, which is great. Let's wait 1 more minute before we begin. And again, because I would like to keep this less formal, if you want, you can put your questions in the chat, which everyone will see your questions, or you can put it in the Q&A panel, and we will answer as soon as possible. I don't want to interrupt Viktors when he goes through his process, but if it's something interesting, I will just ask Viktors. So we are 2 of us here, and we'll try to do our best. I think we'll already have enough participants, so we're good to go. And I hand over to Viktors. Feel free to start.
Thank you. Yeah, hello everyone. So today we're going to take a look at the workflow, how we can use freeform surfacing to recreate some more or less organic shapes and a bit more difficult geometries than that we could easily reproduce with some sketches and lofts and everything. So just to save our time for geometries where precision is not that crucial. In fact, you can get super close, but well, it's just matter how you want to process with your work. So, and considering this workflow is more or less easy, I guess at the end of this online workshop, we could touch the thematics of auto freeform as well for the same part, so we can see the actual difference in between of these 2 tools. And let's just, I guess, start this. Well, yeah, as Kosta said, if everyone has some questions, you can write in chat, or you should also have option to raise your hand if something to ask some question which is about like currently you didn't understand something or something like that. So just raise your hand and we will try to answer you. Well, yeah, so as you see, this is interior panel of car. And basically this project started when some user in some Facebook group asked how to proceed if I want to create here enclosure for speaker. So I need to replicate all these surfaces to be able later to print this enclosure. So let's start with just adding the new freeform. With snapping option on, and basically we just start with creating our first polygon quad. We can enable tolerance. Probably, yeah, it should be okay. So normally you will have this duplicate handle. So you can start to work from it. Just click and drag it where you want to place the next points. Proceed it this way. Something like that. So now you can see that our deviation is a bit off. So we can come over, select just one edge, and click here, right click and split, or you can use hotkey S button to split it. All these points automatically are getting snapped on our mesh, and we see our tolerance is getting way better. But we will talk about this in a moment, a bit later. So what next? I want to move this direction. Probably something like this. Maybe even bigger steps. Later we can again move our edges to control the deviation. You can see how it changes. But at this point, it's not super correct because we have this red point here. And as you can see in this place, we have a bit different deviation right now. That kind of messes up the flow lines of our surface. So we will come over back for some extra massage of our quads when we have filled all this area. We can just start to move over. And you can hold Alt key and just drag one of these red points to your desired destination. This way, we will create another quad. Basically, you also can just select all the lines and with duplicate handle drag a complete bunch of them. But as you can see, pretty often it's not that comfortable because later you have to come back over to merge them, to adjust every of them. So I see this is pretty good option when you can use the Alt key and create just random polygons. And at this point, we have to probably divide them like this. And as you can see, we have different amount of quads here. But basically, if we connect this one here, we will have again this pinch point, which is not good because, for example, if you switch on zebra analysis, you can see that we have not really nice reflections here, so it's not smooth at this point. What we're going to do, we're going to split this one once again. So we have one extra row of quads connected there. And we can select these two and click bridge edges. Okay, so we have complete this panel, actually part of it, and now we can start to adjust our points to reach our desired deviation here. Sometimes this operation can take quite a while, but in my experience, it's really useful to do this because you can get really smooth surfaces later and with really good reflections. And later I will show you what was the difference between this workflow and automatic freeform, and why this is way more flexible tool than automatic freeform. Of course, with automatic freeform, you can do everything way faster and so on, but you have much less control over the process. this, and we have pretty nice tool, brush smooth. Basically what it does, it tries to make spacing between vertices more or less equal. So this way you will get even smoother results of your surface. But in some cases, it's not that useful when you have, let's say, transition of different surfaces. So sometimes you want to have different length of these edges or distance between vertices to get it more sharper, this transition, or smoother. Well, when you are doing your smoothing operations here, you have to take a look at the deviation analysis. So as you can see here, it started to float away. So I'm just going back and keep it as it was. Okay, so let's say we have our first freeform more or less aligned as we wanted. And at this point, we again can go to extrapolate tool to extend its boundaries. And to one side, another side, and it to the bottom as well. Yeah, and then here you can see that we have a bit of deviation in this corner. So what we can do, we can come over here, select, for example, these, and these 4 points, switch off snapping, and we can use I think this time local. Start to pull it away to match your deviation, like that. Probably we want to move these two as well. Something like that. Also, you can later come over back, switch on snapping, and adjust some more points directly on your mesh. Okay, so just click close, and we have our first surface. Let's see how it looks. Pretty much flowing, but as you can see here, we have some ripples. Some ripples here, so we can always just go back to Freeform, edit. Okay, let's move it a bit more. Some regions. And we put up something in this corner. At this point, might be pretty wise not to take a look at your deviation analysis, because considering this panel is covered with carpet, so it's not super smooth, and how the snapping works, it just snaps onto your mesh. And if you have some rougher surface mesh, as here you can see, and some points can be snapped to higher points of your mesh, some vertices can be snapped to lower points of your mesh. So this is what can take, this is what can call the result as we have right now. But you can switch on snapping again. You can switch it off and try to repair this somehow by pulling this point away somewhere. So you can see how the result changes. And then we can do this. So this way we can get our result way smoother, better flowing. And of course, another option, normally when you have snap mode on and you are using the brush smooth, your vertices are still snapped onto your mesh, so it can't make it too smooth. It is making it smoother just by pulling vertices closer or further apart one of each other. But if you have snapping mode off, then it will actually move in the same direction as I just tried to move it. So these are two differences in this workflow. As you can see, we can play pretty a lot with the smoothness of our surface. You get totally different result. First, if you come back and take a look at your deviation analysis, it became way worse than it was. But in total terms, it's like, okay, this time it's 1.5 millimeters and 1.6. So you have to consider these facts by yourself. Is that good enough for you or not? So you need more deviation tolerance, or you want more smoothness of your surface. This is always the question for you as a reverse engineer. How do you want to proceed with your reverse engineering tasks? So you have to consider some facts always. So like same as diameter dimensions, so you have to round it up to some point, or as in this case, you want to align to deviation, or you want to make smooth panel. Okay, enough about this. So we have our first part done. We can add it for now. Go to create another one. Also, we have, for example, in this case, we need way more quads, so we can just come over here and click increase resolution, so it will subdivide all the existing quads. So you don't have to go to each of them and click on split. No, just try to points. Of course, you can play around with this, adjusting quite a long time. Try to align as best as you can, but well, we're quite limited on time, so we're not going to do that. Again, when we have this done, and we're coming to interpolate, so extend it to one direction, another direction, third, fourth. Okay, cool. So we have this part done. Take a look what's happening on each side. Pretty wise to take a look how distorted your edges are after interpolation, because sometimes when you have geometries like this, so it's like a lot of curves, and interpolation works as just extending in the same direction. So if we had sort of bump here and surface close to the top, and you can see this part is not that super nice and smooth. Same as this corner. So you can switch off snapping, come over to the smooth brush. Just brush them to make it a bit smoother. As you can see, it's getting smooth and nice. And on this side, Probably want to move this corner point first a little bit. And then actually smooth it. Okay. This is our second surface. Let's hide it again. So now we have to recreate, I guess, surface in this pocket. But as we have some mesh in front of us, we can always come over to edit scan panel. Select some part of our mesh we don't want to use right now. And click right selected. Okay. So we have clear access to the surface we want to remodel. And then I can come over to the freeform, like this. And probably worth to mention too here is we can change the shading of our mesh. And we have one special, it's a curvature shader. So here you can see where actually your surfaces start to curve on the loft, not the loft, but on the fillet. And it's advised not to go over this edge. It's not advised not to go onto the fillet because then your surface will just start to bend already. It will be more difficult to get deviation on the last row of your quads. And same interpolation won't work that's good. So automatically you'll just try to curl it, for example, this way. It might be quite a lot. We have to work later more. Plus, it will be more difficult to actually match nice corners of intersection of your surfaces. Just see with this. Wrap it. And again, when you're satisfied with your result, but just oversize our surface. Another one, and we need a couple more to finish up all this. So this one's small. For example, new Freeform is super cool tool to reproduce surfaces like this. So normally you would have quite a lot of problems because, for example, on this side it's more or less flat, but here it twists to this direction, and actually here it goes to like completely triangle surface. And this would be extremely difficult to reverse engineer it with some like casual sketches. Because if you have like a completely triangular corner, it will create degenerate surface and you won't have any smoothness there. Basically, you need to define oversized patch of surface and then trim it to have a good resulting surface. And here, this our new Freeform tool is actually super cool and flexible in this case. I'll keep it right now as it is. Disable snapping. Go to local. Now I just extend it. And extend complete edge. Like this. And from here, we can adjust our freeform to match the deviation we need. Like this. We can split it again. We can come over and say snap this edge, then disable snapping again, and adjust it from here. Like this way. And you can come over back. Okay, and this it's snapped. Like this one. Okay, so as you can see, we managed to recreate this twisting surface pretty easily with just 6 points and maybe 2 minutes of adjustment. I just oversize it in all directions, so we're sure it's enough of surface in all directions. All right, this one probably recreate it well. This side panel, again, purely today everything is related to freeforms. So we're not using anything more than freeforms, and it might be boring, but in the past couple months, I found freeform surfacing super flexible in many tasks. For example, when you can't figure out how to recreate some surfaces, when you don't see actual, how to call it, like feature lines, super sharp feature lines or things like that, or you just floating surface with some white blends or something. The freeform can do all of that. And it's way easier and way faster to use this. So we can come over and hide everything. So we have some track. How long surface do we actually need here? Let's extend it a little more. Something like this. And again, we're coming to interpolate and directions. Okay, so we have almost the last surface. Let's hide this one. Let's make surface for our floor. Well, finally, we are using some different tool. Extract primitives, select necessary polygons. Create floor. oversize it. And let's create one last surface, and we will create it by using sketch. So more or less this time it's going to be just eyeballing. So this one as well. Okay, so now 3, 4, 5. Probably we want to create. We want it. Probably we want to create one more surface to make it smoother cut. And let's say we can actually come to here. Let's come over to the construct panel, create reference point. Basically, I'm going just to create another plane based on 3 points selected on your mesh. For example, we'll say 1 point is going to be here. Let's say another point here. And the third one. Yeah. And I can come over, create new plane, constructed, 3 points, select all these 3 points. Okay, 1 point is a bit of the place we want it to be. At this point, it was just snapping to our plane. So the geometry is actually have the priority of snapping in this case. Okay, so we change the location of our point and come over back to create our plane. 1, 2, 3. Okay, we have this plane. Looks actually pretty good. Now let's hide everything. Like this. Let's hide our mesh and start trimming it. I want to delete everything behind this plane. I want to delete everything here. Everything on this side. Everything above this. And of course, everything behind our main surfaces. This, and I'm going to get rid of all these cutting surface as well, and we end up with this blank stuff. It's a single surface right now. Click OK. Let's find our points. So we end up with this. And essentially at this moment, you can start to add some fillets. They're a bit more tolerant. Mm. Then come here. Mm. Okay, we will stop at this point. So yeah, basically, the thing is, mostly people know that with freeform surfaces, you can actually create the same fillets as well. But the difference why I'm using several surfaces is because it's way easier to handle them. So you don't have to recreate a different amount of quad spacing, and if you are not really like experienced person with subdivisional modeling, it might be pretty frustrating and difficult to handle this. And pretty often I have seen results when people come over from, for example, from this stage, you have here like, I don't know, 20 quads, and you move all of them to the one corner. So here you have, for example, like let's say it's one meter length of the edge, and here you have 20 centimeters. So you can imagine this moment when all these 20 points comes to spacing of 1 centimeter instead of 5 centimeter, and if your mesh has some roughness, definitely you will see the bad result there as ripples and things like that, and it will be difficult to handle them. So you would have to switch from like 20 quads to 5 quads on this side, and you would have to actually plan how to proceed with that. And it's not that easy, and it actually takes much more time if you are not an expert in subdivisional modeling. Plus, in this case, you can always come back to any of your fillet and just change its value. We decided that you need there less or more, so you can always come over and change it rapidly. In case if you would have modeled this all as one, you wouldn't have this flexibility. It would be extremely too difficult to actually change fillet and do that constantly, especially. So this is the, as I said, first part of this online workshop, and I would like to touch question about automatic freeform as well. And then I previously prepared, you can see, just cut the mesh apart, so it's easier and faster to just snap out of freeform on it. We can create holes. Let's keep it, let's say medium. What result are we going to have? Okay, as you can see, we have really a lot of quads. So the target quads count was 2000, and actual number of quads at almost 2000 quads. So imagine if you want to move something somewhere and have some control over it, it's super difficult. Okay, we can see that now it's really good from this point of view. Let's hide our mesh. Over to analysis, zebra stripes, and what do we see here? So it's like, it reminds me an ice cube. So here in this part, we had imperfection on our mesh. And all these ripples that you see here is just because of the different places of your mesh where actual vertexes were snapped, as I said previously. So these are like high and low points of your scan data. As you can see, really good example here. You can see these are high points, and this one is a low point. So all this is just making things worse. Yes, it's super fast to create this surface like this, but well, is this any useful for you? It's up to you, of course. Another thing, of course, we can come over, change snapping mode, and just smooth it. Let's say we enable our zebra stripes, and you start brushing it. Yes, it starts to resolve some good, but imagine you have to smoothen all of the surface, so it takes a lot of time. Is it faster at the end? Well, I would say it's not. And probably this is more frustrating to come over and try to brush something completely as you want it to be. So, yes, here you can see the main differences between automatic freeform and the manual freeform. So, manual freeform, you're using less as possible quads to make your surface actually smooth. It's like pretty big difference, as you can see. Of course, this one is not perfect. I'm not telling it's super amazing, but well, you can always come over and do some slight adjustment and to get absolutely good result. In any case, it's way better than result that we got from auto freeform. So, as in all our previous tutorials, we just suggest to use auto freeform for things like castings, where you actually don't have this super tolerances, where you don't really care about how super smooth your surface will be and things like that. Just don't consider it to use anywhere. It's a handy tool, but not saver for all life situations. Another option, of course, we can go and create another auto freeform, but let's say it's low, feature detail low, feature aligned. Okay, let's build more coarse one. Okay, we have way less polygons right now, so it's under 1000. Still, it's quite detailed. If you come over right now, so we have changes and tolerances. Okay, it's good for us. We can always come over here and actually start to adjust it. There. There. Or probably just with adjustment brush. No, in this case, it doesn't work, so you have to do your manual work. Yes. Of course, it's doable. Yes, maybe in some cases this is like super good and super fast workflow to replicate some surface. So all this is up to you. And well, your projects, you decide how you want to finish them, what the quality and what are requirements for that. So I think from my perspective, it's all for today, and If we have some questions, we can answer them. How is it, Costa?
Yeah, it was great. It was just amazing. I really enjoyed it. Thank you. Thank you very much, Viktors. What I really liked here is that you showed the biggest difference and advantages why and when to use automatic surfacing and using the manual one to end up with great results. And you can obviously see, but as you said, it really depends on the application. There is one question I tried to answer to most of the questions in the Q&A sessions written, but there is one open question here, which is there a trick for good expanding of auto freeform? I like this question because, like you said, in the casting modeling, or where we advertise our hybrid modeling, you normally isolate and then you create auto surfacing, then you expand it, then you trim. Now, the trick about this is that you must prepare your object for automatic surfacing. If you look on the screen, the boundaries are not perfect. What I mean is that then the algorithm struggles and doesn't know about the curvature. Yeah, this is what it shows. So don't expect miracles. The auto surfacing is great, but it just, if you give them a good boundaries, then it will work quite well. So for this reason, you can use smooth boundaries, or you can take a look at our tools for boundary improvers, hole filling, and tools like that until you get a good results, and then you can expand. So this is the trick. This is my recommendation.
Well, there's another thing, if we're talking about preparation, of course, like defects like this, you would like to get rid of them before you are doing some automatic freeforms. So this is the thing that will cause a lot of issues. But well, depends on application. Of course, you cannot actually repair this spot by keeping the texture of the rest carpet. So you have to find the actual balance in between of all this.
Okay, another question is, can the auto freeform be split and then split items to be extended? Well, normally there are techniques and strategies. You can split the different meshes and auto surface them separately. Or when you create auto surfacing, you can duplicate them into separate entities and then you can edit. Now, that's the biggest difference in QUICKSURFACE. Automatic surfacing is fully editable. You call auto freeform just to create this, but then you have the freedom to do whatever you want. You can just edit as a normal thing.
Yes, one more thing about this. So normally, for example, if you have surface like this, and because of some reasons thickening doesn't work, you can always come over to your auto freeform, duplicate it, edit it, and we have function of offset. So we can set desired value, say -3 millimeters, and it gets offsetted. And this typically works nearly always. And it doesn't matter what kind of geometries you have made and everything like that, it will always work. Not just like thicken. Thicken may fail because of some sharper corners, super small surfaces that are being consumed due to the thickening. Then it will throw an error and it will fail. But in this case, you can thicken everything, well, almost everything. So this was just one more point. Cool part about the freeforms and flexibility.
Yeah, there is a question about, does offset give smaller radius in the inner? Now, that's the difference between thickening a freeform. It cannot handle these intersections. It's suitable for the freeform where the curvature doesn't change too much and it doesn't guarantee the same thickness everywhere, but it works always. So you may need for the offset surface, you may need to go and smooth a little bit and improve it so you avoid the self-intersections. But it just gives you this freedom to offset virtually every type of surface that you can modify later and achieve some results.
Well, yeah, yes, and well, actually, we can take a look at one more thing. So actually, we have quite a lot of freedom to say this, and let's brush select some more faces. And we have these faces. Let's say we want to add more thickness on this side, or change the surface itself. So we want to make some bump here, or opposite, we want to move it further down to the other side of surface. And this is super good and super fast. For example, when we were looking at workflows for casting parts, so you don't have just to close the hole with some kind of algorithm where you have like it's flat or curved, and pretty often just it is where it is when you want to try to repair a mesh and close this hole. So in this case, you can select the necessary quads and move them as much as you need to have like more meat on your part that you will, I don't know, mill later or process it in a different way. So this is super useful for casting applications. Of course, not only, it can be used anywhere. So adding more volume to your part for later processing is, I think, pretty cool option of all this. So, okay, so do we have some more questions, maybe?
Sorry, I was muted. There is another very good question from Ricardo. It says that the more quads we created, the more precise we get to the scan data. But if we get lower number of quads, then it looks much nicer. This is the fundamental thing about number of points, control points in the cut industry. If you want to make a really good and smooth surface, you must keep the number of points to as low as possible, ideally maximum 3 points. You know, this is the perfect smoothness. Of course, it's not always possible. That's why we have this continuity, G1, G2, G3. But be careful when you increase the number of control points. Yes, then it snaps to the mesh and it captures the imperfection, the noise, either because of the scanner noise or because of the texture of the surface, and so on and so on. So it's really up to you to decide how close you want to be to the underlying scan data. One big mistake is that we always get something, oh, I want to get the cut model as close as possible to the scan data, if possible under 10 microns and so on. And then we can make it. You know, I had an argument on one of the groups. They say, how accurate is your algorithm? We can make it as accurate as you want. You, like Viktor shows you, you just press the button, increase resolution, and we can just get under 1 micron. But how useful these data are, this is the most important question. So it's really in your hands. Okay. Any more questions? Time flies. We are nearly about an hour. I hope we learned a lot about the freeform modeling, and you can combine in your workflows. We'll still be waiting a couple more minutes for more questions if you have some. Variable fillet, it's an ongoing project for our next version. I replied on the chat, but it's upcoming for our next releases, which will be later this year. We work really hard to get the new version of the software much better.
And if we don't have any questions at the moment, I would like to remind everyone that we are always up to your project. And if you have some ideas that you would like to see in our online workshops, just share them with us. If you have some examples, CAN data for that, you can share and we can review them and try to use them in our online workshops. So basically, we are doing these online workshops for you to educate you. So to get more attention of you and probably raise some interest in reverse engineering field. So if you are sharing some ideas with us, so we have what to do, and we are not just doing something, oh, let's do, I don't know, let's do this part or this part, so it doesn't matter. So we want to provide some content that is useful for you. And it's not for us, obviously. So yeah, basically you can write email or you can go to our Facebook group and post there, or just I think this is going to be shared on YouTube as well, so you can drop the comment there as well. So we're open for your offers, and actually we would like to find out what you want to learn and what parts you are struggling with, so we can provide more like concentrated content over these topics. So don't be shy, talk to us, and yeah, share your experiences as well.
Great. Just to say that we already had one object, which I don't want to review right now. We need to get ready for our next workshop. So stay tuned and we'll prepare with Viktors some more interesting stuff. I don't know when it will be, but soon, hopefully in a couple of weeks.
Yes, sort of. More or less, I guess it's going to be as well 3 or 4 weeks from today, and we'll keep the same schedule as always.
I wanted just to add that we've just created a LinkedIn QUICKSURFACE users group. So if you are not Facebook user, you can go on LinkedIn and you can join this group. All of the information about our next workshops will be there available as well. Thank you very much for everybody attending this workshop today. It was amazing to see you, so many attendees today. Amazing.
Thank you. We can finish for now. Thank you. Have a good evening.
Okay. Thank you. See you next time. Bye.